Here, next example says to approach runway 17 of the Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent starting from an altitude of 1,707 feet above the airport. How many miles from their runway is the airplane at the start of this approach? And they gave us a hint that 1 mile is 5,280 feet. So we have an airplane up in the sky, right? And usually all of these are going to be angles of depression problems because your airplane's going straight out, but then he needs to start descending. So we have our little runway right here he's trying to approach. So we make this little triangle with a really small angle. It's only 3 degrees for that angle of depression. And they've told us that right now, the airplane, when it starts descending, is at an altitude of 1,707 feet. So if this is 1,707, again, the nice thing is if this is our ground, we've just made a rectangle. So this is also 1,707 feet. And they want to know how many miles away from the runway did that airplane need to start its approach. So how far is this distance before it starts descending down? Probably an important thing to know, right? We don't want our pilots missing the runways. So we have our little triangle set up. Here's our angle. We need to label our 3 sides. This one would be opposite. This one would be adjacent. And then our hypotenuse is the big side. So on this one, we're using O and A. So we're going to use tangent again. So we get tangent of our angle equals the opposite side divided by the adjacent side. And we're going to have tangent of 3 degrees, just a little angle, equals our opposite side, 1,707, divided by our adjacent side, x. And again, we're just going to switch their place. X equals 1,707 divided by tangent of 3 degrees. We're going to throw that into our calculator. 1,707 divided by tangent of 3. And we get this lovely number, 32,571.5. But the tricky thing here, if this is a Math Excel problem, if you type that into your answer box on Math Excel, you'd get marked wrong. And that's because they said how many miles away is the plane. We just measured this in feet. Remember, this distance was in feet here. So if this is in feet, so is this. So that's why they gave you this little hint right here that 1 mile is this many feet, because they want you to convert it. So to convert this into miles, we need to divide it by that 5,280, and that'll tell us how many miles it is. So if I just divide that by 5,280, we get about 6.2 miles. We'll just round to 1 decimal again. So 6.2 miles from that runway is when that airplane needs to start descending in order to hit the runway on time. So kind of an important thing to know, right? Okay, we're gonna do one more. It says, this one's a Utah one too. To find the height of Delicate Arch in Arches National Park in Utah, the surveyor levels a measuring device with the bottom of the arch. She measures the angle of elevation to the top of the arch to be 48 degrees. She measures the distance from where she stands to a point directly under the arch to be 36 feet. Find the height of the arch if the height of the measuring device is 5 feet. Okay, so we all know what Delicate Arch looks like, right? Here's kind of a bad drawing. Here's our famous arch in Utah. And so we have a surveyor. She has a little measuring device at the bottom of the arch. She's measuring an angle of elevation to the top of the arch to be 48 degrees. And she's measuring the distance from where she stands to a point directly under the arch to be 36 feet. And then it's also telling us that the device she's measuring from is 5 feet high, and that's important. So we've got this little device right here. Let's just say it's like a little camera, I don't know. Or it could be her. But it is measuring the angle of elevation to the top of the arch to be 48 degrees. Okay, so here's 48 degrees. And then they also said that she measured the distance from where she's standing to a point directly under the middle. So coming straight down, we've got this little triangle right here. So this distance right here, they said, is 36 feet. Okay, find the height of the arch if the height of the measuring device is 5 feet tall. So they want to know how tall is this. Okay. But then the tricky thing is this camera or whatever device she's using, it's not measuring straight from the ground. So if this is the ground right here, it's 5 feet off the ground. So when we're finding this distance right here, it's not taking into account that extra 5 feet from where it's standing. So we're going to have to add that additional 5 feet to our answer. If this device had been sitting right on the ground, we wouldn't need to do that. But since this device is 5 feet up, it's kind of skewing our measurement a little bit. So let's set up our sides. If this is our 48-degree angle, we are looking for the opposite side. And then this would be our hypotenuse, the long side. And then this 36 feet is our adjacent side. So it looks like we're using tangent again because we have the opposite side and the adjacent side. So tangent of our angle equals O over A. There's our formula. We're going to plug in the info. We have that 48 degrees. Our opposite side is X, and then our adjacent side is 36. So solving for X, we need to times by 36. And that cancels the one in the denominator. And X comes alone, and then this is what we were throwing into our calculator. So 36 times tangent of 48 degrees. And we get, we'll just round that to 40. Let's just say that's 40. So that's 40 feet, but remember this device is 5 feet higher off the ground. So if this is 40, we want to add that additional 5 feet that machine is not taking into account. So we're going to add 5 feet to it. This is for the measuring device being 5 feet off the ground. So we get a total of 45 feet tall. And that would be your answer. So sometimes they'll try and trick you with stuff like that, where you're not measuring straight off of the ground, you're a little bit up. And so you want to take that into account there. So, okay, but those are your story problems using angles of elevation and depression. Hopefully they make sense now. Let me know if you guys have any questions. I hope you're all doing okay, and I'll talk to you later.